Welcome to Ren's tutor class. So I want us to look at the reading of Vernier caliper and micrometer screw gauge. 4 things we are going to be looking at. Number 1, the reading of Vernier caliper. Number 2, the reading of Vernier caliper with 0 error. Number 3, the reading of micrometer screw gauge. And lastly, the reading of micrometer screw gauge with 0 error. So let's begin with the reading of Vernier caliper. So whenever we are given any diagram of Vernier caliper without another diagram showing 0 error, so that means the reading of such diagram will be the actual reading, that is the actual measurement. So Vernier caliper actual measurement. So let's look at how we read Vernier caliper. The following caliper have no 0 error. Each reading represents the precise measurement obtained by combining the main scale and Vernier scale. So we need to first understand which part of Vernier caliper is main scale and which part is the Vernier scale. So let's look at the A part. You will see that this upward part, that is the top part, is the main scale. Is the main scale. While the bottom part is the vernier scale. So when you want to take the reading of vernier caliper, what you need to do is to get the value of the reading of the main scale, then you get the value of the reading of the vernier scale, then you add them together. So let's look at this one by one. And you need to also have this at the back of your mind that the Vernier scale reading can be in millimeter and it can be in centimeter, depending on the diagram given to you. Like the one we are looking at right now, which is the A part, is in centimeter. But you see the reading of the Vernier scale. The reading of the Vernier scale is always in millimeter. So if the whole reading have to be in centimeter, that is the main scale, so that means you need to convert the vernier scale to centimeter. So let's start. How will you take the reading of the main scale? For you to take the reading of the main scale, check the 0 scale of the vernier scale. So the reading of the main scale before the 0 scale of the vernier scale gives you the reading of the main scale. So look at the 0 for the vernier scale. Can you see the 0? The 0 is just after the 0.2 of the main scale. Look at it. This is the reading for the main scale. You see, 0.2. And that's the reason why the reading for the main scale is what? Is 0.2 centimeter. So the reading for the main scale is 0.2 centimeter. So you go to the vernier scale and try to see where the calibrated line of the vernier scale coincide with the calibrated line of the main scale. And if you look at it, you will find that at this point, can you see at this point? And that is 0.8 because vernier scale always starts with 0.8. Vernier scale always start with 0 point. I mean, I said 0.8. 0 point is of one it's in decimal. That is in decimal like that. So 0 point. So and that is 8. That's 0.8. So convert 0.8 to centimeter because it's 0.8 millimeter. So you convert it to centimeter by dividing it by 10. So 0.8 divided by 10 will give you 0.08. 0.08. So you add it to the main scale 0.08. And that will give you 0.28. And that's the reason why the reading is 0.28. 0.28. So let's look at the B part. So we check for the Vernier scale, the zero of the Vernier scale. This zero is just after what? After 0.5 of the main scale. So that means the reading of the main scale is 0.5 centimeter. And you check where the calibrated line of the Vernier scale coincides with the calibrated line of the main scale. And that is at 7. That is at 7, you can see. At 7, at this point. Yes, at that point. So because of that, the reading for the Vernier scale give us 0.7 divided by 10, which is 0.07. And by the time you add the two together, you will get 0.75. If you look at C, the reading for the main scale, you will notice that the zero is exactly at 0.9 of the main scale. The zero of the Vernier scale is exactly at 0.9 of the main scale. In that case, because the Vernier scale cannot coincide twice, so check where it coincides again, you can see. Because it's exactly at 0.9, it shows that the Vernier scale is 0. You don't need to bother. So that shows that the reading of that Vernier caliper is 0.9 centimeter. So whenever you see where the zero scale, the zero of the Vernier scale coincide with the exact value at the main scale. So the reading of the Vernier will be 0. Please take note of that. So let's look at D. Look at D now. This D is just after a 0 of the main scale. So what's the reading of the main scale? Is 0. The reading of the main scale will be 0. Because the 0 is just after the 0. So there's no value. That's 0. Then you look at where it coincides and you notice that it coincides at 7. That's 0.7, which is divided by 10, 0.07. 0.07 plus 0 will give us 0.07 centimeter. That's the reading. And you continue like that. You continue like that. So let's look at other readings. I told you that Vernier scale can be in centimeter, it can be in millimeter. Take for instance the H part here is in millimeter. Our reading is in millimeter. So that shows that you are not changing anything in this case, except if the diagram given to you is in millimeter and they want you to put your answer in centimeter. And at times, the diagram given to you may be in centimeter and they will want you to put your answer in millimeter. That shows this, our answer here, in millimeter will be 1.15 times 10. And that will give us 11.5 millimeter. If they want us to express it in millimeter. So please take note of that. So let's solve this in millimeter. In millimeter, this is 0, this is 10. This is 0, this is 10, this is 20. That shows that the resolution is of 1 millimeter. So that is to say we have 1, 2, 3, 4. So let's see where the 0 of the Vernier scale. The 0 of the Vernier scale is exactly on 6th division. The 0 of the Vernier scale is exactly on 6th division. So that shows that's 6 millimeter. 6 millimeter. Since the 0 of the Vernier scale is exactly on the 6th division of the main scale, so the reading for the Vernier scale is 0. You don't even need to bother yourself looking for where it coincides, because it will never coincide. Even if it coincides, just ignore it, since it's exactly on the value of the main scale. So the reading for the Vernier scale will be 0. And the reading for that Vernier caliper is 6 millimeter. If you now want to convert it to centimeter, because the actual reading is in centimeter, that means you need to divide it by 10. Divide by 10. And that will give you 0.6 centimeter, which is our answer here. 0.6 centimeter. Okay, let's do more of millimeter. Let's do more of millimeter before we call it another day or another time. Now, let's look at the G part, the I part. Now, it's in millimeter, so the reading before the 0 of the Vernier caliper, you can see, let me draw the line. Look at the 0, see. Here you see. So that shows the reading for the main scale now will be, if this is 10, this will be 5, 6, 7. That's 7 millimeter. You can say 7.00. Then go to the reading of the main scale. The reading of the main scale. The reading of the Vernier scale. The reading of the Vernier scale, where it coincides. You can see it here. It coincides here. Can you see? That's at 6th division. At 6th division. So, and that is 0.06. So add it. So that is 0.06. And that gives us is 0.06. I wanted to write 0.06. I'm writing 0.06. No, it's 0.6. In this case, it's already in millimeter. So you don't need to divide it by 10, okay? That's 0.6, not divided by 10. So this will give you is 0.6, yes. 0.60, you can put it that way. Then our answer will be 0.6, that's 7.6 centimeter. That's our answer. 7.6 millimeter. 7.6 millimeter. 7.6 millimeter. Sorry, pardon me on this. This is a mistake. This is a mistake. It's supposed to be is 0.06. Yes. Not is 0.06. So it's supposed to be 0.6. 0.6, not is 0.06. Yes. Because everything you see in millimeter, you you don't need to convert anything. So since we have gotten 7.6 millimeter, then we can do what we can convert it to centimeter because our answer is in centimeter. And what will you do? You just divide it by 10. Divide by 10, and that will give us 0.76. 0.76 centimeter. So that's the reason why our answer is in 0.76 centimeter. So this is an error. I think I'm going to correct it in the next video. So this J, let's do this last one. It's also in millimeter. So since it's in millimeter, so that shows that the reading for the main scale will be 11. You can see it because this is 0 for Vernier scale. That's 11. So that's 11. Yes, like that. You can see. So this is 10, then 11. So we have 11 before the 0 of the Vernier scale. So the reading of the main scale will be 11 millimeter. So 11 millimeter. So what's going to be the reading of the Vernier scale? It coincides at the 5th division. So if you say this is 0. If you say that this is 11.00, then it should be plus is 0.5. In this case, 50 is 0.5. Then you add them together. You have 0. So please don't mind this. It's 0.5 because it's in millimeter. So this will be 0 plus 5. Then this is 11.5 centimeter. That's the answer. The 11.5 millimeter. That's the answer, 11.5 millimeter. Then to leave our answer in centimeter, so that means 11.5 divided by 10. And this will give us 1.15 centimeter. And that's the reason why our answer is 1.15 centimeter. So that's how to take reading of Vernier caliper. So in the next video, I'm going to be teaching you how to take a reading when 0 error is given. This will be useful for those of you that are doing A-level or advanced physics. I think you can see that in JAM or WAEC or IGCSE or any O-level physics. So in the next video, we'll be doing Vernier caliper with 0 error. So you can share and comment, and you can ask questions if you have any. And by the grace of God, in the next video, when I see those questions, I will give you a reply. Yeah, thank you, and God bless you. Yeah, bye.